Recycling is something most people do without thinking. We toss plastic into the yellow bin, paper into the blue one, glass into the green one, and that's where our awareness usually ends. But the real story of recycling begins after the garbage truck drives away. What happens next is a massive industrial process, full of advanced machines, lasers, sensors, and technology that most people would never expect. If you like similar educational content, please like, subscribe, and share the video with your friends. To understand how recycling truly works, we need to go to the place where every sorted item begins its second life. The materials recovery facility, also known as the sorting plant. A sorting plant is a huge building filled with conveyor belts, noise, mechanical arms, scanners, and industrial separators. Everything that enters the building is mixed, chaotic, and dirty. The goal of the facility is to turn this chaos into clean, separated raw materials. When the truck unloads the waste, it's spread out on the receiving floor. Workers do an initial manual check, removing oversized items or materials that could damage the machines. Large metal pieces, electronics, dangerous waste, soaked cardboard, dirty containers. Only then does the actual sorting begin. Waste moves on to conveyor belts, where an entire fleet of technologies identifies and separates each material. Near-infrared sensors, NIR, detect plastic types based on their chemical structure. Ballistic separators divide light 2D materials, paper, film, from heavier 3D objects, bottles, cans. Magnets remove steel. Eddy current separators repel aluminum. High-pressure air jets push plastics into different bins. Optical cameras detect contaminants and remove them with pneumatic arms. Plastics are sorted into PET, HDPE, PP, and other categories. Paper goes to its own stream. Metals go into steel and aluminum streams. Glass, often collected separately, gets its own sorting step as well. This moment is crucial. Here, waste stops being trash and finally becomes a raw material. And once each material is isolated, its journey splits into completely different recycling paths, each with its own machines, temperatures, chemistry, and limitations. Now we move into the core of recycling, the actual processing of each material. Every material goes through a completely different journey. Plastic must be washed and melted. Paper must be dissolved and cleaned. Metal must be melted and cast. Glass must be crushed and remelted, and each of these processes is a full industrial operation with its own technology. Recycling plastic. The most complex of all plastic is the hardest material to recycle, not because it's impossible, but because there are so many different types. PET, HDPE, LDPE, PP, PS, PVC, each with different melting points, densities, and chemical structures. After sorting, plastic enters industrial washing lines. Here, absolutely everything that might reduce the quality of the recycled product must be removed. Food residues, oils and grease, glue and labels, dirt, inks, organic contamination. Once cleaned, the plastic is shredded into small flakes. These flakes then go through multiple stages, flotation tanks that separate different densities, rinsing, drying, sieving, optical sorting, removal of metals or micro-contaminants. When the flakes are clean and uniform, they enter the extruder. Inside the extruder, the plastic melts and is pushed through fine metal screens. As it exits the machine, it forms long spaghetti-like strands that are cut into identical pellets, the final product known as regranulate. This regranulate becomes the raw material used to produce things like new PET bottles, textile fibers, fleece, carpets, jackets, packaging film, industrial containers, caps and injection molded parts, automotive or technical components. However, each recycling cycle weakens the polymer. This loss of quality is known as downcycling, meaning the new product is usually lower grade than the original plastic recycling paper, the cycle of cellulose. Fibers paper recycling is much simpler. In a paper mill, collected paper is mixed with water inside massive drums, forming a pulp called paper slurry. This pulp is cleaned through, filtering, removing staples, plastics, sand, chemical de-inking, flotation cleaning, washing, and thickening. The clean pulp then enters a paper machine, which can be over 100 meters long. The pulp spreads across a moving mesh screen. Water drains away through gravity and suction. The sheet passes through heavy presses that squeeze out more water. It moves into heated drying cylinders. Finally, it's wound into giant rolls of new paper. Recycled paper becomes cardboard packaging, newspapers, office paper, kitchen towels, toilet paper. Paper fibers can be recycled up to 6 times before becoming too short and weak to use recycling metal. Nearly infinite metal is one of the most valuable recyclable materials because it can be remelted almost endlessly without losing quality. Steel and aluminium are processed differently, but both undergo sorting, shredding, decoating, removal of paints and lacquers, melting in large furnaces, casting into ingots or slabs, rolling or pressing into sheets and profiles. Recycled metal becomes car parts, new beverage cans, construction components, electronics, tools, and structural pieces. Recycling aluminium saves up to 95% of the energy needed to make aluminium from bauxite ore, one of the biggest environmental wins in materials science. Recycling glass. Perfect circularity glass is one of the only materials that can be recycled infinite times without degrading. The process is straightforward. Glass is crushed into cullet, cleaned, separated by color, melted in furnaces, formed into new bottles, jars, and containers. Using recycled glass, cullet, significantly reduces the melting temperature, saving fuel and lowering CO2 emissions. All these materials, plastic, paper, metal, glass, now exist again as raw industrial resources. But the story doesn't end here. Not everything can be recycled. Some materials get downcycled, and the quality of the collected waste influences everything that comes next. Now that we've transformed waste into clean secondary raw materials, the next stage begins, turning these materials back into real products. This is the moment where recycling stops being about trash and becomes a full-scale industrial production cycle. And even though most people imagine recycling as processing garbage, this phase is one of the largest manufacturing sectors in the world. How recycled plastic becomes new products. The regranulated plastic pellets are shipped to factories that use injection molding machines, extruders, blow molding machines, vacuum forming lines. Each machine reshapes molten plastic into new items. Depending on the factory's needs, recycled plastic becomes packaging containers, industrial crates, new bottle preforms, plastic caps and lids, electrical housings, piping and construction elements, textile fibers for clothing and carpets. Many products today contain 30% to 100% recycled plastic. But because recycled plastic loses strength and elasticity with every cycle, factories often mix it with virgin material. This creates downcycled items, useful but not as high quality as the original product. How recycled paper returns, as new paper mills take the cleaned paper pulp and feed it into colossal machinery that shapes it back into usable material. Here's how recycled paper becomes product again. The pulp spreads evenly over a fast-moving screen. Water drains through the mesh. Heavy rollers press the sheet to remove more water. It travels through heated drying cylinders. It is trimmed, smoothed, and wound into large rolls. Rolls are cut into individual sheets or fed into packaging production lines. Recycled paper turns into cardboard boxes, packaging inserts, writing paper, paper bags, newsprint, tissues, and toilet paper. The number of times the fiber has already been recycled affects the final quality. How recycled metal becomes new steel and aluminium. When recycled metal leaves the sorting plant, it goes directly to smelters. The process, shredded metal is heated to extreme temperatures, coatings and paints burn off or are removed mechanically. Liquid metal is cast into new shapes, slabs, coils, ingots, rods. These shapes are then rolled or pressed into finished metal components. Recycled steel and aluminium become vehicle bodies, beverage cans, construction beams, electronic casings, machinery parts. The quality is as good as new, which is why metal recycling is one of the strongest pillars of circular manufacturing. How recycled glass becomes new glass enters a near-perfect circular loop. Crushed cullet is cleaned, mixed with sand and chemicals, melted in giant furnaces, blown or molded into bottles, jars, insulation fibers, and glass panels. With glass, the recycled content can reach up to 100%, and the end product is indistinguishable from one made with virgin materials. Why some items still can't be recycled. Even with advanced technology, not everything is recyclable. Some items are simply too contaminated, too complex, or too expensive to process. Food-soaked packaging, greasy pizza boxes, multi-layered foils, paper plus plastic plus aluminum in one, coffee capsules made of mixed materials, colored plastics with problematic pigments, products glued together in a way that prevents separation. These items often end up being incinerated for energy or sent to landfills. But here's the good news. New technology is radically changing the game, and the future of recycling looks completely different from what we know today. We've seen how recycled materials are sorted, washed, shredded, melted, and transformed into new products. But recycling doesn't end there. The final piece of the puzzle is understanding why recycling matters, why it sometimes fails, and where the entire industry is heading. This is where technology, economics, and environmental science come together, and where the future looks drastically different from today. The environmental power of recycling isn't just about reducing waste. It fundamentally changes how much energy, water, and raw resources the world consumes. Massive CO2 reductions. Recycling aluminum saves up to 95% of the energy required to produce new aluminum from ore. Recycled plastic and paper also reduce emissions dramatically. Less waste on landfills. Landfills release methane, a greenhouse gas far more potent than CO2. Every item diverted from landfill reduces these emissions. Less mining and drilling. Every ton of recycled metal means a ton of ore that doesn't need to be extracted. Every ton of recycled plastic reduces demand for new fossil fuels. Huge water savings. Producing paper from recycled fibers uses far less water than producing paper from wood pulp. In short, recycling is one of the most effective tools we have for reducing our environmental footprint. Why recycling doesn't always work. Even the best technology cannot compensate for bad sorting at home. Contamination is the #1 reason why recyclable materials are discarded. Items that ruin entire batches include greasy or food-soaked packaging, wet or moldy paper, mixed material products that machines can't separate, broken ceramics mixed with glass, plastics contaminated with chemicals or paint. When one bag of trash contaminates a full load of recyclables, the whole batch may end up in landfill or incineration. Recycling is only as strong as the people who participate in it. The circular economy, a new way of thinking. The world is shifting from make use throw away to designing products that can be reused or recycled from the start. This is the foundation of the circular economy. Key trends include mono-material packaging that is easy to recycle, labels and adhesives designed to wash off easily, packaging made for reuse instead of single-use, deposit return systems for bottles and cans, biodegradable and compostable materials, increased recycled content mandates in manufacturing. In the circular model, raw materials circulate through the economy again and again, rather than ending up as waste. The future of recycling, driven by technology. The recycling industry is undergoing a high-tech revolution. AI-powered sorting robots that pick items with human-like precision, laser and hyperspectral scanners that detect materials by chemical signature, fully automated sorting lines running 24/7, chemical recycling, which breaks plastics back down into molecular building blocks, advanced recycling of batteries and electronics, national deposit systems drastically increasing return rates, smart packaging that tells machines exactly what material it's made of. These technologies are transforming recycling from a raw mechanical process into a highly precise industrial system. The real goal of recycling is not just about waste. It's about keeping materials in circulation, reducing environmental damage, and ensuring that the Earth's resources last longer. When recycling works properly, plastic becomes a new bottle or fiber, metal becomes a new car part, paper becomes a new box, glass becomes a new jar, and waste becomes a valuable resource, not a burden. Recycling is a global ecosystem, powered by people, machines, industries, and innovation. And every properly sorted item can live a second, third, or even 10th life,